Hello everyone, it's Mrs. Davitt here, and today we're going to look at another Chapter 10 circle topic, and that is intersecting chords. So chords are segments that cut the circle across and intersect two parts of the outside of the circle. So one example is AB, and one example here is CD. And those two chords intersect at point E, so that's labeled for convenience as we move through some further examples. So, let's think about what relationships these two chords might form. In order to do that, I'm going to add two segments here to create triangles. So I'm going to add segment AD and segment CB. Okay, so now I have formed two triangles. Now I want you to think about what relationships might exist between these two triangles. Maybe you've noticed that there is a pair of vertical angles. Now this is interesting because vertical angles are always congruent or equal in measure. So we know that the measure of angle AED, this angle right here, and the measure of angle CEB, this angle right here, are equal because vertical angles are congruent or equal in measure. Do we know any other angles that would be equal? Well, let me bring your attention to this arc BD. Can you find two inscribed angles that open to arc BD? I see angle DAE, which if you extend it connects to point B and opens to this arc, and angle BCE, which if you extend that connects to point D and also intercepts that arc. So in fact, we have a second set of angles that are congruent or equal in measure because they are both inscribed angles that open to arc BD. So this is interesting because now I have two triangles, this larger one, triangle AED, and this smaller one, CEB, that both have two sets of congruent angles, which means that the two triangles are similar by angle. So this is going to help us show a whole host of things of what we can do with our two chords. So let's take a look. So here again is my simplified diagram just with the triangles. So if we know that these two triangles are similar, AED and CEB, then we can set up a proportion with their corresponding sides. So if you look at this diagram, side AE would correspond to side CE, so we can make a ratio, and side ED would correspond to EB. So that's why I have this pair of proportional sides down here. AE over CE equals ED over EB. So let's simplify this because there's a lot of letters floating around here with these labels, and it's not always going to be A, B, C, D, and E on our points. So if we just label these segments of the chords A, B, C, and D, and this is important, where A and B are like the two pieces of one chord, and C and D are the two pieces of another chord, broken up at point E, then we can rewrite this proportion to look like this. And then you can probably see that we could easily cross-multiply to rearrange that to look like this. Now, this may look simple and kind of random right now, but this is huge for us because that means that anytime we have two intersecting chords, we can use this relationship. So let's see that in action with a couple examples. Looking at example 1, we are given segments DE, EC, and BE, and we're asked to find segment AE. So let's label up the pieces that we know. And now let's label this with those parts A, B, C, and D based on the last example where we discovered that relationship. Okay, so again, just to reiterate, it's really important here that A and B in that formula are parts of the same chord, and C and D are the two other parts of the other chord. Okay, so from here, let's go ahead and set up the relationship. If AB equals CD, we can plug in the values 10, 3, 6, and x. We can solve for x, and we would get x equals 5. And x equals 5 is our final answer because we're just looking for AE, and that is the segment labeled x. So that's kind of a simple example of how to apply the two chords, but notice here that we didn't have to draw the triangles, we didn't have to prove that they were similar. That relationship holds based on the exploration we already did. And then example 2, let's see. So if CD is a diameter, that means it's cutting the circle in half, right? And they give us those 3 segments. They want us to find the area of the circle. Well, let's start again just by labeling up the pieces we're given. Let's set up the relationship, A, B, C, and D, and we'll plug those values into the formula. We'll solve for x and get x equals 2. Now, why does that help us? Because if x equals 2, then we can look at the entire diameter as a value of 11, which means the radius is 5.5. So now, if we're asked to find the area of the circle, we can pull our area formula, pi times the radius squared, plug in that 5.5, and get the area of 30.25 pi units squared. So just by looking at 2 intersecting chords, we can do some pretty sophisticated things based on similar triangles. Thanks again for joining me.